Hey, welcome to a little bit of a review from math. This is my first podcast, and joining me today with a little jam on guitar is my daughter Devin. Okay, we're here to do a review on 7.1, which is solving a linear system graphically. So what we're going to do is we're going to head over to our 4 steps that we wrote down in class. Each step is independent and should lead you towards the solution if you follow each step in order fully. So step 1 uh, basically says write out each equation in the form that's easy to graph. The easy way to say that is just put the thing into slope-intercept form, which is your y equals mx plus b. Step 2, we're going to graph both equations on the same graph. We're hoping when we do this that we're going to get 2 lines that intersect. That is going to be our solution. Step 3 is estimating exactly where they intersect and pulling out a point or an address, or more correctly, an ordered pair. That ordered pair, again, is going to be the solution. Step 4 is just plug the ordered pair back into the 2 equations and make sure they check out. And that's it. So let's take a look at a problem that we did in class. This is example 2, which you're also going to see in your book. X plus y equals negative 2. We're going to take that from, let me get another pen here. We're going to take that and do x plus y equals negative 2. And I'm going to take the x and put it on the other side because I want to isolate the y. And the reason I want to do that is because I want it in the form y equals mx plus b. So by adding a negative x to both sides, I get a y equals, and I'm actually going to write the negative x first and then the negative 2. This is in a form I can graph. So let's go ahead and graph that. My y-intercept, or the b, is negative 2. So I'm going to come down here to negative 2, put a little red dot. Now my slope is negative 1, which my slope is equal to the rise over the run. My rise is negative 1, my run is 1. So a rise of negative 1 puts me here, and a run of 1 puts me right here. So let me go down and get a line. Let me draw that going through our 2 points. Adjust that a little bit. There we go. Now, notice it's a negative slope, so my line goes in this direction. That's just a quick check, and it goes through negative 2 on the y-axis, so that's good there. Now I'm going to take my other equation, equation number 2, which is 2x minus 3y equals negative 9. Again, I'm going to rearrange this to y equals mxb form. I'm sorry, y equals mx plus b. In order to do that, I'm going to add a negative 2x there, add a negative 2x there. Gives me a negative 3y equals negative 2x minus 9. Now I'm going to divide by negative 3, and then divide this whole entire thing by negative 3. Not just one term, but all the terms by negative 3. That's going to leave me a y down there equals negative divided by negative gives me a positive 2/3 x. Negative 9 divided by negative 3 is negative equals a positive. 9 divided by 3 is 3. Y equals 2/3 x plus 3 is our second equation in a form that's very, very easy for me to graph. Let's go back over to our graph. Our y-intercept is 3. 1, 2, 3 puts me 3 spaces above the origin on the y-axis. That is my y-intercept. My slope is 2/3. With a fraction, it's very easy to see that the rise over run is 2 over 3. So rise of 2 is 1, 2, puts me here. And then a run of 3, 1, 2, 3, puts me right here. Now I have 2 points, and we all know that 2 points is all that I need to draw a line. So let me draw that right there. Come down and get my points so I can bring it down, make it a little bit more accurate to my points. How's that? Now, I'm going to take a look at my intersecting point, and I'm intersecting right there, which is 1, 2, -3, and 1. So that's my ordered pair where they intersect, -3 and 1. Now, I'm going to go to another screen here. And I'd like to plug this in. Actually, let me bring over my 2 equations. You know what, I'm not going to be able to do that, so let's just do it right on this page. If I plug a -3 in for x and a 1 in for y into this first equation, I'm going to have -3 plus 1 equals -2. Bringing that down, -2 equals -2. That does in fact work, so we'll check that as true, or a solution to this equation. Now I'm going to bring the second equation, and I'll do the exact same thing. Plug this ordered pair in for the x and the y to see if they balance out. And I'm going to find a little space over here. 2x minus 3y equals -9. I'm going to pull my x out and bring in my -3. 2 times -3 minus 3, and again, pull out my y, and my y in the ordered pair is 1 equals -9. 2 times -3 gives me a -6, minus 3 equals -9. And of course we know if we add a -3, I get -9 equals -9. And again, I'm going to check that as true or a solution to this equation. Since that point is a solution to both equations, then we can call it a solution to the entire system. Now let's walk that through again, and this is right out of your book. First step, we're going to write each equation in a form that's easy to graph. And we did that earlier, and this is what we have. And the book breaks it down so you see your slopes and your y-intercept. Then we graphed it. This is the graph of 2x minus 3y equals -9, and this right here is the graph of that. Step 3, the 2 lines appear to intersect right here, and that point, of course, is -3, 1. -3, 1, and we'll call that our ordered pair, or our point of intersection. So assuming that this is the answer, now we just need to check it. So in equation 1, I plug it in. I plug in -3 for the x and a 1 for the y. That comes directly from the ordered pair. And I do the same exact thing for the second equation. And you see they worked through in the book exactly how we worked for it a couple moments ago. And since it's a solution to each equation, then it is a solution to the whole system. Okay, thanks for listening to my first podcast, and to take it away is my girl Devin. She learned how to play guitar all by herself, and she can jam pretty good, as you're about to see.